बिस्मिल्लाहिर्रहमानिर्रहीम। आज हमारे पास जो बेसिक रेडिकल्स पढ़ रहे थे उसमें आज फिफ्थ वन है। पहले हमने कॉपर और क्रोमियम को देखा, फिर फेरिस और फेरिक को देखा, और अभी जो है वो आपके पास है कलरलेस सॉल्ट। जो रेडिकल है उसमें कैल्शियम है जी। अब कैल्शियम +2 जो है ये सेकंड ग्रुप का कैल्शियम मेंबर होता है, इसलिए +2 इसकी वैलेंसी है। तो इसको भी आइडेंटिफाई करने का बिल्कुल जनरली अगर हम डिस्कस करें तो वही दो तरीके हैं। फर्स्ट यू आर गोइंग टू परफॉर्म द ड्राई टेस्ट and then we have a faggy guess about the cations present within the salt analysis. Laterly we will perform the wet tests in which we are going to confirm our special sort of the cations. So going toward that of the dry test identification of the radicals, color of the salt was noted at first. That is a very common thing. We go while ever we are going to pick up the salt, we observe the color of the salt, and here salt is purely white, or in other words we can say that is a colorless salt. The colored salt, which are copper, ferrous, ferric and chromium, that were discussed earlier in the previous lectures, are absent. Whenever we are going to look up into the color of the salt and we have some sort of color, there is a tendency to be the presence of the copper+2 ions, ferrous, ferric or the chromium ions. But right here that the salt is the white in nature, so these color salts are absent in it, at all. Next one is the flame test. Flame test was applied. Brick red flame appeared. Brick red flame, that is the normally flame color of the uh, uh, fire as well, we can say at the normally cooking time we can observe it. ब्रिक रेड कलर जो है बच्चा, ये एक ऐसा ही है जैसे आपकी ईंटें रेडिश कलर और इसकी होती हैं, और ये तकरीबन फ्लेम के अंदर कहीं ना कहीं अपीयर हो रहा होता है समहाउ। तो राइट एट दिस प्लेस वी आर गोइंग टू ऑब्जर्व द सेम कलर। तो जहाँ से ब्रिक रेडिश कलर आ रहा है, हम जो है वो इसे इन्फर कर सकते हैं कि देयर कुड बी द कैल्शियम+2 आयंस। Then the third one test is the filter ash test. In the filter ash test, there was the no color of the ash found. It means zinc+2 ion is also absent, because only color of the ash is being performed by the zinc+2 ions. So it means कि zinc is also absent right here. And the brick red flame जो flame test में हमें appear हुआ है, that is indicating that the calcium+2 ions are there present. Okay, now there comes the turn of the wet test, where the confirmatory test we have to add up original solution with that of the salt containing original solution is actually the salt containing calcium ions, so that is why we term it as original solution. And we are adding up another salt, that is the ammonium chloride, and also हेक्सोसायानोफेरेट, पोटाशियम हेक्सोसायानोफेरेट। यहाँ पे आपके पास एक उसका जो है ना फेरिस का कम्प्लेक्स साल्ट डाल दिया गया। याद रहे कि कम्प्लेक्स साल्ट के अंदर ये जो फेरिस और हेक्सोसायनेट पड़ा हुआ है, हेक्सोसायानोफेरेट पड़ा हुआ है, ये वाला पोर्शन जो ब्रैकेट्स के अंदर पड़ा हुआ है, दैट इज़ अ परमानेंट वन, दैट इज़ अ नॉन आयोनाइजेबल पार्ट ऑफ द आयन। ये पूरा एज अ होल एक आयन बनाता है -4 में, और पोटाशियम +1 के साथ एक आयन बनाता है, तो ये भी आयनाइज हो जाता है, NH4+1 बनाता है, और Cl-1 यहाँ से भी। ये दोनों साल्ट्स को आपने ओरिजिनल सोल्यूशन के अंदर ऐड कर दिया। Whenever we have added up, we tried up to find out the color of the salt, the white precipitate is found, और इससे कंफर्म हुआ कि कैल्शियम जो है वो प्रेजेंट है। अदरवाइज we have seen in the previously lectures that the colored salts have some sort of the color of the precipitates, येलो कलर भी आ रहा था, लाइट ग्रीन कलर भी आ रहा था। फेरिस और फेरिक के केस में जो है वो आपके पास अल्टरनेटिव कलर्स आ रहे थे। सो राइट हेयर इन दिस केस द कैल्शियम इज प्योरली कलरलेस और द वाइट साल्ट, सो द प्रेसिपिटेट वुड ऑफ द white color precipitate will form. In the next step, the second one, that is the addition of original solution to the dilute H2SO4 solution. Right here in this case, in deep diving to this equation that is being explained right background, calcium chloride you have, that is the pure salt or some sort of the original solution that has been prepared from the calcium chloride salt. we are adding up the H2SO4, the sulfuric acid. So salt as a whole is the neutral but having a little bit basic character because of the calcium ions, while the H2SO4 is sort of the acidic character, that is a purely a sort of the mineral acid. So the hydrogen and this one chlorine from the calcium chloride combine to form the HCl, another strong acid, and another salt of the calcium sulfate has been prepared, that is of the white color, because calcium ions have the white precipitate or look up while in form of the salt. In the third one, there is another combination between the sodium phosphate. Sodium phosphate is also a salt, and we are going to combine it with the calcium chloride, and as a whole we obtain the sodium chloride, another salt, and the calcium salt of the phosphate that also will have a white color. All sort of the precipitate that has been formed in confirmatory tests are of white color. These white color are continuously indicating that the ion that is being present right here is the calcium ion, which is purely white. As we have taken the salt, it was the purely white color. And lastly, we are having the calcium chloride with that of the sodium hydroxide, and this combination is giving us the sodium chloride and calcium hydroxide. Calcium hydroxide is a base, in fact, that has been replaced by the sodium hydroxide. In fact, in previous case, in case of the reactants, we have the sodium hydroxide while calcium chloride. So replacement of the ions has been taken place, sodium chloride, and then generating the calcium hydroxide. That is barely basic in nature, as it has the basic character, but that base is a little bit less basic as compared to that of the sodium hydroxide. Okay, the color of this base precipitate are white in nature. Again, as calcium ions are present in these all sort of the species, so these are the major products of your test, while we are going to try some sort of indication about the calcium you have been required. So in case of the performance of the wet test, we have confirmed that the calcium positive 2 ions are present in all sort of the reaction, and its confirmatory test has been confirmed through the observations that white color PPT have been formed in all of these reactions. Hopefully this reaction is clear. Do you have any sort of issue? Let me know. Okay. Next we are heading toward that of the barium salt. Okay, barium salt, again barium is a member of the second group, A, 2A, that is the beryllium, magnesium, calcium, strontium, barium. So barium is also the member of the second A group. Again we are going to perform some dry tests and wet tests for confirmations. While heading toward that of the dry tests, that is the identification of the radical, we are going to little bit have an idea about the salt through identification of its color, note down while it is the white, so we can guess colored salt are absent but could be the calcium or barium as well, because in the previous case of the calcium we also have noted the same color of the salt, white was identified, and we also made some sort of inferences that the colored salts are absent right here. So same is the inference in case of the barium salt as well, because salt color is white. Now we are going to perform the flame test. Flame test is going to make some sort of the difference than that of the calcium ions while detecting in the calcium ion test or calcium salts. Here the barium salts are going to give you the yellowish green flame appeared, where in the previous case of the barium we were getting up the brick red color of the flame. Right here is the yellowish green color, so some mixture of the zinkish look could be the flame as well. Barium plus 2 is indicated because yellowish green is the property of barium plus 2 ions. Next we are going to perform the ash filter test, where no characteristic color of the ash has been identified, therefore it is confirmed that the zinc plus 2 ions are not present, because as we have discussed in the previous calcium time or in sort of the other previous discussions about the basic salts, that only the characteristic color of the zinc or characteristic color of the ash is formed by the zinc ions only. So whenever you have no characteristic ash color, it means zinc is absent. So in the previously we have two sort of the identifications, right? In this case, up to these three basic ideas, while noting the color of the salt, that was white, so no color ions are present right here. Second, the flame test is confirming about the a little bit confirmation about the barium plus 2 ions. These are the physical tests in a sense that we didn't have confirmed these tests by the performance of the some chemical mixtures which are going to be used as a confirmatory test. So for making us confirm about the presence of the uh, barium plus 2 ions, we are going to perform the confirmatory test with the original solution of the barium chloride, yani barium salt, plus dilute sulfuric acid. In the previous case, we have reacted the calcium chloride to that of the sulfuric acid, but right here we are performing the barium chloride and sulfuric acid, giving us the white precipitate, which confirms that the barium plus 2 ions are confirmed. One thing I have to make you clear that in the previous case, original solution when mixed with the dilute sulfuric acid, they also gave the calcium white precipitate and the calcium ion was confirmed. But keep in mind, we also performed the flame test in barium and calcium as well. When flame color is yellowish green and white precipitate from the dilute sulfuric acid are obtained, then barium is confirmed. While in the calcium case, the flame color gives you the brick red precipitate or brick red color of the flame, and again the original solution of the calcium chloride to that of the dilute sulfuric acid is making you to form the PPT of the white color, which will confirm the presence of the calcium ions. So the major difference right here is the color of the flame that is making here the difference, as well as the confirmatory test has been done right here. Okay, next we have the original solution, again the barium chloride solution, also called the original solution, and an oxidative solution, that is the potassium chromate, K2CrO4. We are going to obtain up the yellow precipitate. Purely yellow color precipitates are so delicious in look, the eye-catching sort of the sight could be the seen while discussing about the while performing the experiment, especially in test tube. I personally performed these experiments in the lab, and these are so eye-catching. So yellow precipitates are one of my favorite color when you are going to perform the experiment in the labs. So white color salt at identification or look up, the first look we are having the white color salt, and secondly the precipitate are in yellow color while performing with that of the potassium chromate solution into that of the original solution of that salt. The yellow precipitates are confirming that barium is right here present. One more thing I have to make you realize, that the color of the yellowing precipitate is also getting some sort of the synchronization through the yellowish green flame as well. So you are getting the yellowish two shades in the flame or the dry color or in the dry test as well, while in case of the wet test as well. So go ahead with this confirmation that the barium plus 2 are present right here. And the last one is basically the ammonium carboxide. Let me confirm it. Diammonium C2O4 is I didn't guess about the name of this pure salt of the some sort of the chemical compound could be used in the laboratory. I didn't know its specific name. Okay, now we have the original solution and salt of ammonia. We can consider it as the salt of ammonia. I think so that is an oxalic acid salt of ammonia. Oxalic acid is basically the uh, uh, two carboxylic acids joined to each other, and whenever we are going to remove those hydrogen ions with the ammonium ions, we get this one sort of the solution, ammonium oxalate solution, if I am not wrong. I think so that is the most probable chance that the ammonium oxalate solution is being mixed right here with the original solution, and we are getting the white precipitate soluble in the acetic acid on heating. while in acetic acid, because right here that is a part of the organic in nature, therefore acetic acid is also a part of the organic acid, so a little bit sameness in the group has been matched, and therefore it could be the soluble while on heating. Again, this thing is confirming that the barium plus 2 ions are present. So getting into the detailed discussion of the equations, first of all, we have the three type of the equations. All of them have the original solution. So original solution is of the barium chloride, or the original solution is basically the solution of some salt of that ion. So right here we are having the barium chloride, while in the first case we have the sulfuric acid that is producing about the hydrochloric acid as well as the barium sulfate. So another alternate salt has been generated. Barium chloride is being shifted here to that of the barium sulfate, white precipitate. Barium chloride is being shifted into the barium chromate, yellow precipitate. Barium chloride is being shifted into the barium oxalate. So these all sort of the three compounds have been formed, or the salts that have been formed. It shows that there are the two barium sulfate and oxalate having the white precipitate, while that of the chromate have the yellow precipitate, and these all three confirming the presence of the barium ions. Hopefully this lecture is clear to you. Do you have any issue regarding this lecture? Let me know.
No, I don't have any issues regarding this lecture.
It has been recorded. I am going to upload this lecture. And what is the strategy about the next class?